All right, good afternoon, everybody. Sorry, I was just trying to get some stuff organized. Let me know if you can hear me now, and we are gonna jump right into today's session. Okay, awesome. So what we're gonna try to do, as you guys have should have seen, the notes that I sent you were some summary notes. It gets straight to the point, and it has some questions that allow you to see how the content is used. And so what we're gonna try to do is try to run through this handout so that on Monday we could look at some actual questions. Sounds good? So let me know if you ladies are ready. Um, it's easier for you to just print this handout because it's easier to just have everything printed and you can read it anytime you need. So what we're gonna do, we're gonna read through it together, make sure you guys understand the important specific things, and then look at how questions are formulated and how to answer them. So these are some terminologies we're gonna need to know and remember, especially on the vectors. And the truth is, vectors and matrices are related, but they're like siblings. One requires diagrams and understanding the graph, and the other is really a lot about the arrangement of numbers. So let's go into vectors introduction lesson 1. So we see here we have to solve vector problems at CXC level. You will need to understand the following terms. So we have the position vector, the displacement vector, the collinear vector, equal vectors, parallel vectors, and resultant vectors. And honestly, that is it. Once you understand what these terms mean, how to identify them and calculate them, you will be good to go. So let's jump into the actual definition of a vector. Now, a vector is a quantity that has magnitude. And what does that mean? It has size. That means it actually have a value that is represented by a number or a digit and a direction. So as we see here, we know how we should read a graph. This is the x-axis and this is the y-axis. And so we have a line. But why is it not a regular line? As you see here, the line has an arrow on it that suggests it has what? A direction. So everybody see that? That's the difference between a regular line on a graph and a vector. A vector must have a direction and it must have a quantity assigned to it. No, because it's going in a direction, we must relate that direction in two ways, in the way of the x and the way of the y. So before I continue, are you guys following? Remember, we did this with graphs, with the x points and the y points. Okay, so when we look at our vector, we see here that it has a starting point at A and it has an ending point at B. So the size of the vector is how many along the x-axis did it run and how many on the y-axis does it run. So let's see, we want to go from A to B. We could use a x path. So let me just use the line. So if I want to go from A to B, it's like you're walking. Instead of going straight to B, I could walk this amount to the right. And let's count how much that is to the right. That's 1, 2, 3, 4 to the right. So as you see here, it's an X movement of 4. Everybody following me so far? And what type of movement on the Y, or what type of up movement? How much movement up? 3 going up. So our Y value is 3. And so vectors are represented in different ways, but you have to understand this basic concept that for me to go from A to B, I had to go 4 to the right and then 3 up. Everybody see now? So that's the basics of vectors. Understanding that vectors are straight lines with a direction that is indicated by an arrow, and the vector has a movement. It has an X movement and it has a Y movement. And what is our X movement? Obviously, we count the number of boxes. and it's 4, and it has a y movement, and when we count upwards, it is 3. All right, so let's look at how we could represent this information in different ways. So we're going into vector representation. Now, this probably might be the most important part, because students just get the 3 confused or they forget. The first one, or the first way a vector is represented, is using the end starting point and the end point. So this tells me that my beginning point is A and the ending point is B. What is also another important part about this representation? Is it just A and B? What else y'all seen about this representation? Y'all not seen it? You only seen A and B? What else is a part of the representation of the vector? Not just the starting and the end point, but also the arrow to the top. This is the most important part. You know why? A regular line would just be AB, because you will go from point A to point B. But a vector must have a direction. And so the arrow tells us that we are moving from A to B. No problem. Everybody following me so far with the first representation of a vector? Let's go, guys. Feedback, 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 feedback. Because we really just looking at how vectors are written, what a vector means, all these stuff. So Gwen, Javante, are you with me? Even if you're just looking on, just let me know if you're here right now. All right, so as we know, again, let me just quickly touch on what a vector is. A vector is a straight line with a specific direction and a specific quantity. And the quantity is measured by the direction it's going. So for example, if I'm moving from A to B, that is 4 spaces to the right and 3 spaces up to get to B. And so we have our X value, which is 4, and our Y value, which is 3. And there are different ways of representing the vector. Our first way of representing the vector is using our 2 letters and our arrow representation. Now, the next way to represent a vector is by stating the X and the Y value. Now, I just want to show y'all something. When we were learning about the X and Y coordinates, how did we learn it? We learned it with the horizontal brackets in it, X and Y. Everybody remember that? Okay, but when we do vectors, they use the vertical representation. So the X gonna be to the top and the Y gonna be to the bottom. That's the only difference. And that's the only thing you need to remember. So don't get confused. It's the same thing. It's just that this is when we're plotting regular graphs, and this is when we're representing the vector. So we know the X tells us the movement from left to right. The Y tells us the movement from up and down. Agreed? Because let's look at the example we had before. You see why they put 4, 3? Because here, how much times did we go across? It's a positive 4. You realize we're going to the right. So it's a positive 4. So X is 4. And Y is positive 3 because we're going up. So let me ask you a question. Suppose we were moving to the left, 4 to the left. Would it be positive 4? So let me just move this over. Let's have some questions. Let me see if we're thinking. Exactly. If we know moving to the right is positive X, moving to the left must be a negative. So I just want to highlight something quickly. Let's say I give you this vector, 2, 4. What does this vector tells us? This vector tells us that we move 2 times to the right, 2 boxes to the right, because it's a positive X. Everybody following me so far? And this 4 tells us we move 4 spaces upwards because it's a positive Y. But if it was -2 and -4, what direction we move in? This would put us to 2 to the left on the X, and -4 would give us 4 down on the y. Everybody with me so far? So this is just how we represent vectors. The first number, which is at the top, is our x. The number at the bottom is our y. When both terms are positive, our positive x is right movement. A positive y is an upward movement. A negative x is a left movement. A negative y is a down movement. So just to get some quick notes, write this down, please. So if we have xy, we know we move in, and x is positive. Positive x means right. Positive y means up. But if we had a negative x and a negative y, this means a negative x means left movement. So let me just put movement so we remember, because keeping in mind vectors move. You're moving from one place to another. So left movement. So this is just something to keep you or to remind you. So if a positive y is up, a negative y is obviously what? Excellent, excellent, excellent. Down. So I'm just going to go back up from the top quickly after you guys copy this down. So this is what negative x means. This is what negative y means. So we're going to just go back to the notes that I sent you guys, and I really need y'all to print this out and have it. So everything we do should be added to these notes that you have or should have already. So we have our vectors, which again is any given line that has a direction and a size. What represents the size? We need to look at what type of movement is happening. Our starting point is A and our ending point is B. So how do we move from A to B? Don't worry about that. Let me just move it a little bit. Okay, we're focusing on just this area here. All right. No. So as I was saying, so we have three ways we could represent a vector. And what we've discussed so far is the first one that identifies the starting point and the ending point, and the arrow that tells us the direction in which we're going. So we know that this vector going from where? Point A to point B. Then we have the column matrix. And as I was saying in the beginning of the class, that matrix and vectors are brothers and sisters. They're related. So they're going to intertwine in many cases. And so the column vector is where we have the movement of the actual vector. So this tells us what? This vector is going where? 4 to the right and 3 upwards. Everybody following me so far? And the last one and the most common one is they use small letters. You realize why it can't be a capital letter? We use capital letters to represent points. So we use common letters to represent an entire vector. So we're going to look at some other content. So for those who just came, just follow along. When we start doing the examples, a lot of what I'm saying going to start to click because you would have missed the opening remarks and discussions. So keeping in mind, we got 3 ways to represent a vector. A, B with the arrow, the column vector with the numbers, and the common letter. All right, so let's go. We have the size of a vector. How do we calculate the size of a vector? This is the formula. We're using Pythagoras theorem. So most people, you wouldn't have done Pythagoras yet. That's the next topic we're going on to in geometry. But for the purpose of understanding, most of you would be aware of this one. The square root. And in this example, what is 4? What did 4 represent before? 4 represented our x value. So it would be x squared plus y squared. So this is something I need everybody to copy down. The size of a vector And keep in mind, these words mean the same thing as size. Modulus, magnitude, length. CXC uses all three. Some years they're going to say ask you for the modulus. Some years they're going to ask you for the magnitude. Some years they ask you for the length, but all of them means the same thing. What is the size of the vector? So the formula for the size of the vector is the square root of x squared plus y squared. Let me know if you got it so we can move along and look at some examples. All right, so let's go back up. Let me just show you guys what we've covered so far. So we've covered the definition. We've covered how vectors are represented. And for those who missed it, we need to start looking at the difference between these types of vectors, because this is where the questions come in and they ask you to prove, they ask you to calculate these different types of vectors. So let's look at the first one and probably the most important one, the position vector. Remember, a vector is just a starting point and an ending point going in a specific direction. All right, so let's look at what we have here when we look at the position vector. Everybody see the point A? And remember, point A is just a point. So everybody see the point? And what are the values of the point? So you have an X and a Y value. So which one would be the X in this example for our point A? Let me see if we remember how to read coordinates. So you got 2 and 3. Which one is the X and which one is the Y? Excellent. 2 is our X, because remember, X always comes first. Very good. And Y is equal to 3. And the more you go along, you're going to realize a lot of these things we've done already. It just a little different based on the topic. All right. So the position vector is created using 1 point and connecting the 1 point to the origin. Anybody remember what the origin is? The origin is where X is 0 and Y is 0. So this middle point right here that we label O. So everybody see what the origin is? We spoke about it when we did the Cartesian plane, when we did the whole X and Y axis thing. So somebody give you a point, you plot the point and you draw a straight line from the origin to A. And you realize, what direction should I put my arrow? We always go from the O to the point. So this is how the arrow, the vector would be drawn. So guess what? It's the name of this vector. So if we look at the second drawing, you realize they got a 3 representation. They have the first representation, which is OA, using the 2 letters, aka the starting point and ending point. Do we see it? So we have OA, because where is our vector going from? It starts at O and it ends at A. So let me know if you got that first one. So the first representation, if you see it and you understand it so far. Good. Anybody see the other representation? We see the vector representation. And so you realize they use the vector representation, which is just using the point A. You realize we didn't use any other point, because what is the point of origin? The origin can always be 0, 0, because X is 0 at the origin and Y is 0 at the origin. So obviously the vector for OA is just going to be the X and Y of A. So you put 2, which is the X first, and 3, which is the Y after. Everybody understand that one as well? Let's go, just confirm and keep going with me, because this is where I can't go along if y'all not following me, because this is the basics. This is the foundation. Anybody else seeing the other representation, the third one? So we have the 2-letter one. We have the vector column one. Anybody seeing the third representation? The common A. So you see here, you have the 3 of them. 1, 2, 3. The 3 different ways to represent one given vector. How are we feeling? We feeling good so far? because we're moving through. Everybody feeling good to go? So far. Okay, that's all I need. A common A, exactly. Because we use capital A's, capital letters to represent the points. As you see here, so good question. Look at what we use to represent point origin, a capital O. Look at what we use to represent point A, capital A. So the vector has to be represented by a common A. And if you look at the handout again, if you read the handout, all of this notes is in your handout. How to represent vectors these three ways: the 2 points, the actual coordinates, and a common letter. All right, so let's take it to the next side and look at some questions that give us some examples about our position vectors. So let's look at this diagram here. This diagram now is going to highlight something called a displacement vector. But do anybody see the 2 position vectors? Let me zoom in a little bit. Are you guys seeing the 2 position vectors? Because this now is where you're going to see how position vectors are used. So Janella says yes. Anybody else seen the position vectors? What is the sign of a position vectors? A position vector always starts off with what? In O, because a position vector always comes from where? The origin. So we got 2 of them. What's the first one you're seeing? I see OA. So let me use yellow to represent OA. Remember, it always starts from the origin and goes out to the point A. Everybody seen OA now? Don't not forgetting, you can never forget your arrows. You have to always remember your arrows. Seeing it now? And let's look at the next position vector that starts where, again, at the origin, and it goes to point B. So you see the next position vector is OB because it connects O to B. Everybody see now? OB. And what do I use to represent the arrows? You can't forget the arrows. If you put it without the arrows, it's going to be wrong because you remember 2 capital letters is a straight line, but a vector has direction. Don't forget that. A vector must have a direction and a size. Okay, that's the difference between the 2. All right, so let's look at it. In this example, they didn't give us any common letters to represent the actual vectors, so we're not going to focus on that. But what do you realize here? When we join or create a triangle, or when we connect point A and point B, do you realize we end up with a whole new vector? And you know why it's called AB? Why is it called AB? Because where are we starting? Look at the direction of the arrow. The direction of the arrow says A to B. So that's how we get AB. So to get AB, what did we add together? You realize we added 2 vectors together? So AB is what we call, so OB is the position vector because it started off here at the origin. OB is the position vector because it started off at the origin. But is AB a position vector? That's what the point of this whole discussion is. Is AB a position vector? It is not, because first thing first, AB was created using A and B, and that's what we call a displacement vector. When a vector is created by 2 points that do not include the origin, it is called a displacement vector. Displacement vector. So that's all I want us to focus on. Identifying what? Our position vectors and our displacement vector. So a displacement vector is in red. So talk to me, everybody, so far, how you feeling? Because now we have our blocks, because these are our building blocks. Understanding the position vector, understanding the displacement vector is, hello? Y'all hear me? Okay. Okay. So as I was saying, once you understand the building blocks of the types of vectors, when we start learning the actual laws, it's going to be clearer and easier to understand. All right, so just confirming me, we good to go. We good to go. You follow me so long. And again, if you realize you have to read over the notes on your own, make sure you do so. Okay, because remember, we crunching in a lot in a short time, but I'm going to try my best to break it down as much as I can. All right, so let's just read what we have here. In the diagram above, OA and OB are called position vectors, as we know, because their starting points are taken relative to the origin or from the origin. Same thing we were saying all the time. Let's look at the next sentence. The starting point of vector AB is not the origin. So the term displacement vectors is used to tell you the difference between this type of vector and a position vector. So that's it. So you see, we understand when a vector starts at the origin and when a vector don't start at the origin. Once it starts at the origin, called position vector. When it's not started at the origin, it's called displacement vector. That is it. All right, so let's move on to an example, which I love, because this is where we start to make sense of the information that we just learned. So before I go down, I'm going to just see if y'all could pick up on certain things. So we see example 1, points P, and what are the information for point P? 3, 2. And which one is the X and which one is the Y? Don't ever be afraid to label your information. So let's go, class. Which digit is the X and which one is the Y? Is it 3 is the X? Very good. X is 3. And which one is Y? Y is 2. Very good. And for the next point, so you realize we got a P and we have a Q. And both points will always have an X value and a Y value. So they have position vectors OP and OQ relative to the origin. Express OP and OQ as column vectors. So I'm going to write it. OP with my arrow. OQ with my arrow. So they gave us some information here. So let me use my black. What information they gave us? They gave us point P coordinates, right or wrong? Let's go, guys. Talk to me, because remember, you're here with me. I need to know if you're with me. Anybody could tell me what the points or the coordinates for P is based on how they gave it to us? Excellent. 3, 2. And what is the points for OQ? -1, -3. So if we want to represent this as a vector, and because we know it's a position vector, we use the actual points. How do we represent it now? As column vectors. Remember, we spoke about that? All we need to do is turn it vertically. So instead of it being horizontally, so instead of it being 3 next to 2, how is it going to look? 3 on top of 2. This is a very common question CXC asks. Everybody see now? Because this is simple. It's pretty easy, but you just got to understand what you're doing and why you're doing it. So remember, we spoke about the different types of representation. So you see, this is the column representation. Good. So the answer for the column vectors for OQ, again, you write the X on top, you write the Y at the bottom, and that's it. Everybody see that? Pretty straightforward. And we're going to do some more examples, obviously. So that's the first one. Next one, express PQ as a column vector. Now, this is where I need to teach you something. This is where we're going to learn something new. But before we continue, everybody with me so far? Okay. Before we move on to this one, I'm going to go back up here. So let me just erase all of this. what we're going to be looking at is following the arrows or following something. So let's look at our triangle. We want AB. If we want to create AB and we want to follow the points, how can I do that? I need to add the two vectors together, right? And as it stands, how are the two vectors located? So let's write it down. The two vectors are what? OA, right? With the brackets. Everybody following me so far? All right. All right, so let's go. I want to travel to get to from A to B. Suppose the straight line wasn't there. That's the point of adding two vectors. Remember, the answer is what you get when you add the two. So let's go. I am located at, so let me erase all of this. Let me see if we're going to think, because this is just a visual thing. So follow me. We starting up at A. And let's say nobody ain't carve out a path. You're on a field. And there's two paths so far. They got path OA and AB. What do you realize here? How can I get to B? I got to go back where? If I am at A, where should I go back first to get to B? Minga, go back to the origin. Should I redraw this? Let me redraw it just in case. Let's take nothing for granted. So I'm going to reconstruct this entire thing so we could see it from scratch without the lines already drawn. So this is my A and this is my B. And what we have so far is our position vectors. All right. No problem. And this is our O. All right. So let's go again. Guys, somebody on a field map out two pathways. As it stands right now, there's no direct connection or path to A and B. It's all bush. How could you get from this point to B? Where would you have to walk if we are currently at A? What line of walking you have to do to get to B? You got to go back to which point first? You have to go back to the origin. Everybody see now? But what do you realize about going back to the origin? Isn't that the opposite direction of OA? Everybody see now? So that means we have to walk towards AO. That's where we walk. We walk from A to O, right? And then we have to add the next line that we're going to walk. Where else do we walk now? Where can we walk if we're now at the origin? Where do we need to walk now to get to B? Along which path? OB. And you realize here we walking in the same direction of OB. So I could just write what? OB. Everybody seeing this? This is the basic concept of AB. And how do I know if this is correct? You see this in the middle here? The two middle points must be matching because you can't walk directly to 2 points if these 2 points ain't the same. Everybody see that? These are the connecting points. O is the connecting point. Everybody see that? Talk to me, talk to me, talk to me. Because if you don't see it, I got to do it all over. Because the most important part is understanding how do we travel. It's like you're traveling. We want to get to point B, but we cannot just walk from A to B. So we need to go back to O, which is the opposite. So it's not OA, it's going to be AO. So I'm going to put my arrow here to say we went from A to O, and then we went from O to B. Everybody see that? So this is what we call the triangular law. So AB, and this is equal to AB, because this is where we ended up from. We moved from A to B by traveling from A to O and then O to B. This is an entire law in vectors. This is probably the most important law, which is any 2 points. You want to go from one point to the other, but there you don't have a direct line. you have to do something. You have to say AO plus OB is how you get to that point. And keeping in mind, what must match? Your two inner letters must match. No, something else I'm gonna teach you. It can show up in the it can show up in the notes, but I just want to teach you it fast here. If I tell you, look at this. If I tell you A to B, A to O to A is a positive movement, what you think gonna be the movement going back from A to O? Based on what we just learned. If forward is positive, what gonna be backwards? Yup. Yup. Negative. Everybody see that? So just take it in now. I'm just explaining the concept so that you can understand it now, and then we're gonna put it all together. Okay? So don't panic. It might be a lot of information right now, but it's just for you to get an understanding of what we're looking at. So the truth is, guess what? These two things are equal, but they have different signs. So look at this. OA, sorry, I'm writing OB. OA and AO has the same value. It's just that AO is going to be the negative of OA. So let me show you what I mean by that. Same content, right? You want AO. So AO is equal to negative OA. And which one is the original one? OA is the original one. So if we want AO, we just add a negative sign to it. Let's add some letters. If I tell you OA is letter, let's say common letter A, what would be AO? Ain't gonna be negative A. Right or wrong? All we did was do what? Add a negative sign. So just keep this to the back of your mind as we move through, and we're gonna start to make sense of everything that we're doing right now. So let's go back to the example. So far, we know how to represent a column vector, boom. And what I like about the solution here is that they don't just work it out. They always show you what your diagram. So let's take a look at the second question. So you see here, based on the diagram, we were correct about our position vectors. So they drew. Let me zoom in a little bit more so you guys can see. Everybody seen it? So we had OP. Remember, OP is just from the origin to the letter P. And then we had OQ, which is again the same thing, O to the letter Q. And so the vector would just be X and Y in it. And look at this as well. Look at where the vectors are positioned. What do you realize about OQ? You realize it went 1 to the left and 3 down versus OP that went 2 to the right and 3 and 2 up. Tell me if you've seen it. The movement from the origin. So Gwen says she sees it. Anybody else sees it? The difference between when the X is positive and the Y is positive, and when the X is negative and the Y is negative. Because remember, a vector tells you how a point is moving, how the position is moving. All right. Okay, so let's look at the second question. What did the second question ask us? The second asks us to express PQ as a column vector. But what is the problem here? We don't have PQ yet. We got to find PQ. Agree or disagree? So before we look at the answer, y'all want to try it? Y'all want to see if you could work it out even without looking at how the answer is, and see if we could get it together without the notes? If y'all willing to try, we could try. So Gwen says yes. Not okay, good. What did we just learn? I can't just go from O to P and O to Q. They're going to just be two separate directions. I want to get from what? What are we looking for? We're looking for P, Q. Everybody see that? So which letter has to switch? Which one have to switch? OP need to switch or OQ need to switch? Who needs to come first? What do we have to start off with? We must start off with what? P, right or wrong? So instead of OP, what are we gonna have instead? PQ gonna equal to what? P, O, very good, plus what? And OQ. Let's look, let's follow the line. Let's follow the line. We want to go from P, O, and then OQ. OQ. Everybody see that? Same thing like what I just teach you. Just following the lines. We gone from P, then we went to O, and then from O, we went to Q. But guess what? Did they give us PO? No, they didn't give us PO. How do we find PO? PO is just the negative value of what? OP. We just gotta make OP negative. And it's plus OQ. Tell me if you're following me still. Where did this negative come from? Because remember, we ain't following the direction of the arrow. We're going in the opposite direction if we want to go from P to O. So we need to make OP negative. Right? So how do we make it negative? If I put a negative here, boom, and I have 3, 2, what's going to happen to the numbers inside? Both of them going to become what? Excellent. So eventually, and look at us, we ain't even looking at the notes. You realize we're figuring all of this out together without even looking at the answer. So you see, I hope y'all are realizing that vectors isn't hard. People think vectors are hard. Vectors isn't hard. It's just making sure you understand how to look at the drawing and how to interpret the data. So if I multiply negative to a positive number, what's going to happen to it? It's going to become what? Negative 3, negative 2. Plus negative 1, negative 3. Everybody following me so far? Keeping in mind, talk to me. So keeping in mind, what do we have here? We have an X and we have a Y. We have an X, we have a Y. So what do you think we need to do if we want to add this? We should only add what? The 2 X's and add the 2 Y's. So I am just going to group it in one big bracket. So I'm going to start off with my negative 3, put the plus sign, because remember that's what we're doing in between here, plus my negative 1. That's going to give you one answer for your X. Now for your Y's, you're going to go negative 2 plus negative 3. And at this moment, we should know what's going to happen here. What is called, guys? This is called what? Clashing signs. So what is it going to turn into? When a positive and a negative come together, it turns into a negative. Positive and negative come together, it turns into a negative. So what we're going to end up with is minus 3, minus 1, negative 2, minus 3. And so my final answer, when these signs are alike, we added 2 numbers and put back the sign. So we're going to get negative 4, negative 5. Everybody see that? Let's see if that's correct, even before checking. So this tells us what type of movement. To go from P to Q, this is what? 4 left from P and 5 down from P. Let's see if that's true. Let's look at our diagram. So how much they say 4 left? Is it 4 left? Let me see again. Something happened to my screen. It kind of crooked, but the box is still there. So let's count how much left we had to go to get to Q. So let me erase all of this. We say 4 left and 5 down. So let's see. That's one box, or let me use red. That's one box left, 2 box left, 3 box left, 4 box left. Yes, that's correct. Let's see how much down. Let me use a different color. Let me use green. That's 1 box down, 2 box down, 3 box down, 4 box down, 5 box down. So you see that is correct because it correctly gave us the right coordinates to get to Q. Everybody see that? Remember, that's what a vector tells us. A vector tells us the direction and the size of moving from one point to another. Everybody see that? So let's look at the actual solution just to solidify what we just did. So let's look at this diagram and make sense of everything that we just looked at. And guys, everything I'm doing, the notes have all the explanation. So let's say I'm going a little fast and you want to go over it, print out the notes and everything we're talking about, you can see it right here. Everybody see what I'm saying? So don't at any point in time feel overwhelmed. Don't feel like if you don't get it now, you're going to be lost, because all of the information is actually just, and I love the language they use. They break it down simply. All right. So just take some time to review the content. So let's go again. And for those who joined us after, don't feel overwhelmed. Just follow us and pick up what you could pick up until you get a chance to read through the handout. So you realize, what did we try to do here? Let's recap some very important stuff. We have 2 position vectors. And what are our position vectors? Whenever our line starts at the center or the origin and goes towards the point. So our first position vector is called OP, because we started off where? We started off at O and the line ended up at P, and we put the direction because it went from O to P. Then we had a next position vector. And why do we call it position? Because it starts at the origin. So we have a next position vector that started off at the origin, which is what? OQ. So it started off at the origin and it went to point Q. Keep it in mind, the arrows. Look at the arrows. The position vectors always tells you the direction. Right? And so what we ended up with is OQ with my arrows. But what the question asks us to find? The question asks us to find PQ. So that means we need to figure out, how can we go from P all the way to Q? We must use our vector law, triangle law. And you see why it's called a triangle law? Because when you connect all the points, what type of shape it makes? Let's go, guys. What type of shape you see when you connect all the points? A triangle. So that's why they call it the triangular law. So the triangular law tells us, if we want PQ, we need to start doing something. We need to start at P, because we want PQ. We want to go from P to Q. So we can start at P. And then where do we have to go? We got to go back to the origin. So that means we need PO plus, and after we reach the origin, how do I get from to Q? I go from O to Q, which is represented by what? OQ. Right? And that's how we got this formula here. What they did here too is the same thing what we did. We want PO from OP, so we just had to add what? The negative sign to it. Everybody remember us doing that? So everything we did before, it's exactly the same exact thing. Same exact thing. Same exact thing. All right. What was the third question? The third question asked us to find the length of PQ. That's easy because we know the formula for the length. So I'm just going to come to the side here. How do you find the length or the size of any vector? So the size or the length has a formula that we don't talk about. The square root of the x value square plus the y value square. And in this example, what we're trying to find the length of PQ. And PQ, we don't find the answer. How much was PQ? -4, and -5. Keep it in mind. Which one is the x? The first value is always your x, and the second value is always your y. So all you need to do now is substitute. Everywhere you see x, what you're going to put? So let's work it out. I'm going to put back my square root. What should I put first inside here? Remember, it's a -4, eh? So -4, thank you, square plus -5 square. So if we were to work this out, we should remember any negative times a negative is a positive. So you're going to get 16 plus 25. And when you add those two numbers, what do we get when we add those two numbers, guys? Calculator people, you should have your calculators. Very good. The square root of 31. So you have two options. Some people would just put this as the answer and put units. But because we have calculators, what do we get when we square root 31? Everybody here should have a calculator, and you need to make sure, even if you ain't really 100% confident, practice using your calculators. It's 41. That's true, because 10 times 30, that's 41. Agreed. What's the square root of 41? I got 6.4. 6.40 units. You got 82. You should use square root. Let's see if that's what I get. 6.4 units. The only thing they didn't do is put units, but you need to put units. All right, so before I continue looking at anything else, everybody following me so long, because we can't move on unless we understand this basic concept. Pretty straightforward, right? So we're going to do one example on our own and see if we could work it out. So I'm going to give you 2 points. I'm going to give you point M and N. So points, and we're going to sketch it too, because you have to learn how to sketch graphs. Point M is 3, 2. And N is 6, 5. So the first question is express as vector columns. Both OM and ON. B, find MN as a column vector as well. And the last one, C, find the size of MN. So copy down this question in your books, guys. You need to have this example in your books. So when you copy down the question, let me know. And then we are going to practice it before we move on to the next part. To be honest, vector questions just come like this. This could be a CXC question. And that's what I like about vectors. It seems difficult, but it could be just as simple as these 3 questions. So just say done when you finish. So one person done. Okay. All right. So when it comes to vectors, you have to sketch a graph because it's going to help you visualize everything and kind of remind you what to do. So what we should do first, we should plot these 2 points in it. So we're just going to sketch it because they didn't expect you to use no graph paper. It don't need to be completely accurate. They just need to see that you know what you're doing. So I am going to plot my 2 graphs, well, my graph, and you realize why am I doing this version and not why am I using this version and not the second one? Anybody know why? Because that's the next thing. Let's discuss that before we even continue. How come I'm not using this bigger graph? Anybody realize here? So let's discuss it. If you don't know, you need to tell me you don't know why, because that's the next thing. So I can know how to explain it. Do you know why we should use this type of sketch graph and not the second one? We know this is the X, this is the Y. This is the X, this is the Y. So Gwen said no. Anybody else have an idea of why? Okay. What type of points am I using? Look at the points. What do you realize about the points here? X is positive, Y is positive. X is positive, Y is positive. If I had a graph where I had some negatives, everybody see what's going on here? If 0 is in the middle, and we know 0 is called what? The origin. Based on my point, all of my points going to be in this section. That is why I use in this L, which is this. Everybody seeing that? But, so in this case, what do you realize? If your X is positive and your Y is positive, you're using this path. What has happened on this side though? You realize we on the top, so Y is positive, but is the X positive on this side? What has happened to the X on this side? If this is 0, what happened in going this way? There's going to be negative X values. Everybody see what's going on now? What about this section here? What happening in this section here? What type of X we have on that side? Excellent. And but what type of Y we have? Everybody, let's go. Do we have a positive Y? If this is 0 here, anything below this line, Y is negative. Everybody see that? So look at it. Starting from this line going this direction, X is positive. And anything before this line, X is negative. Anything above this line, Y is positive. Anything below this line, Y is negative. Everybody see that? So let's look at this section here. What is going to be the value of the X in this section? What type of X do we have on the left-hand side? A negative X. And what type of Y do we have below the Y-axis? A negative Y. I'm going to draw a quicker scale so that you could see with the numbers so that it could kind of stick in your brain a little better. So you have your Cartesian plane, and you're only using your Cartesian plane when you got points in all different sections. Everybody see what I'm saying? So let's look at some numbers now. If in the middle is the origin and in the middle is 0, 0 for the X, 0 for the Y. So going to the right, this will be positive 1, positive 2, positive 3, positive 4, positive 5. But before 0, what you're going to end up with? Negative 1, negative 2, negative 3, negative 4, negative 5. And what type of axis is this? This is the X-axis. Everybody following me so far? Now above, if this line again represents 0, above gonna be 1, 2, 3, 4, 5. But below, what we gonna get below? Negative 1, -2, -3, -4, etc. So as you see here, right-hand side is positive x. Left-hand side is negative x. Above is positive y. Below is negative y. Everybody with me? Y'all seeing it now? So when you're looking at points and you want to plot a graph, these are the things you need to be thinking of. What type of points do we have? We have all positive x and y's. So do I need to go and draw this whole entire x? No. All I need is this section here that allows me to draw positive x and positive y. And that's why we choose this type of graph. So now, does everybody understand how to choose your graph? So remember, math is about thinking, making connections, using the best options. So you don't give yourself a bunch of work and draw all 4 when you don't need all 4. So let's sketch now. Let's sketch. We know this is 0 in the corner here. And what type of points we plotting? We plotting just up to 5. So I could use a scale of 1. So each dash would be 1 for me, right? So this is 1, 2, 3, 4, 5. And you realize I'm not using a ruler to measure out. When you're sketching, it don't need to be perfect. So don't go get a ruler and measure out these here. You're not getting a mark for the graph. But if you draw the graph and you make a mistake, CXC would acknowledge you and give you some marks for at least understanding what you're supposed to do. Everybody understand what I'm saying? And honestly, it's the difference between a 2 and a 1. A student who wants a 1 would use this, and a lecturer would see, oh my God, she knows what she's doing. Okay, this is a 1 student versus a student who just trying to calculate and write the answer. All right. So for vector questions, always sketch your graph. Always, always sketch your graph, because it's going to help you. It's going to help you see what you need to see. So let me just erase all of this because it's a bit distractive. Move this down. So we have our sketch graph. So if you pick the wrong graph, you get the question wrong. No. And trust me, the more we practice, the more you won't even have to worry about picking the wrong graph, because it's gonna click. All right, so let's go. We need to plot these 2 vectors. And we have these 2 points. So let's go. M. How do I plot M? I go looking for 3, 2, because X is 3. Y is 2. So this is just us practicing the graph in general. So let's go. We're going across 3 and we're going up 2. So let me just use my little dotted lines. We're going up 3. Let's pretend this straight, guys. Let's just pretend it, it's looking like I'm just plot it. 3, 2 should be here, isn't it? Everybody agree? This is M. That looking like it? 3, 2, come across 3, go up 2. It looking like it in line. Let's back check quickly. So I went across 2, come down 3. So everybody see how I get my point M. Let's look now for the next point, which is N, 6, 5. So let's get my stuff and look for N, which is come across 6. So I didn't put enough. So I need to put another dash here for 6. Okay. And I need to go up 5. Do I have enough for 5? Yep. So I come across 6 and I go up 5, go up 5. So this looking like it here. So this is looking like my N. Everybody see now? Before I continue, everybody understand how I got my point N and M? All right. Now, since we're looking for the position vectors, all we need to do to make the position vectors is what? Join it to the origin. Everybody see that? And that's it. So we know eventually they're going to ask us to find MN. So what we do, we just take our line and we connect it to make our little triangle that kind of look a little like an obtuse triangle, but that's okay. So let's go from here. So you could use both the graph, and you know why you're doing this? sometimes CXC will give you the graph and you got to get the information from the graph. So you see why you're doing both. If they give you the point, you should be able to find the vector. If they give you the graph, you should be able to find the vector. Everybody with me? So we're doing two things at once. We're looking at the facts and we're looking at the graph. So it doesn't matter if CXC gave you this graph and say, what is the two column vectors? You know, you just need to find whatever M, the point M is. So you just find the coordinates for M, you find the coordinates of N, and you write them as a vector, column vector, like that. So all we need to focus on is X and Y. So because we see the graph, we understand how it looks. We don't even need the graph to do this because we already have the points. So let's go. What would be OM? OM with the arrow would just be this information here rewritten in the vertical form. So instead of 3, 2 next to each other, it's going to be what? 3, 2, like this. Just like that, you get easy marks for a question in CXC. Just like that. That's it. That is it. How do I find ON? And keeping in mind, what type of vector is OM and OM? These are our position vectors because they start from the origin or the center of the graph. So let's go. What would be my ON vector? What number should be to the top? 6. Everybody see now? And we'll be getting 6 from, remember, you'll be using the coordinates of N. So this would be our X and this would be our Y. So it's going to be 6 because the X always comes first. And the next one is going to be what? 5 because the 5 always comes second. Keep it in mind, you're just rewriting your X and your Y. Your X and your Y. So we have correctly answered A. So even those who joined late or those who just come in, do you at least understand how we got the vector, the column vectors for OM and ON? So I see Trev and T. Talk to me, y'all, okay? Y'all picking up something a little bit? All right, so that's our answer A. Now let's look at B. And like I said, B is probably the most work you got to do. It's the most work, but ain't the hardest work. It's probably the easiest work. It's easy, but it's just the most work you have to do. So let's go. We know we want to find MN. And what do we know? MN is the resultant vector. And for me to get from M to N, where do I have to go first? Where's my starting point again? Remember, you got to follow the track. You're going to start off at M, right? But you got to go back. And my mistake is that, what did I mistake and do here? What did I have wrong here, guys? I'm missing something. What must I always have on my vector lines? The arrows. So this is something I forgot, and this is something you can't forget. In addition to that, what else did I forget to do? Label. I needed to label that this is ON with the arrow, and this is OM with the arrow. Everybody with me? So let's go. We want to move from point M to point N, and we have to pretend like this red line not here. So we gotta go the long way. So where we need to go from? We're gonna start off at M and we need to go to O, and then from O, we go to N. So we're gonna write that out as a formula, and we know that's called what? The triangular law. Because we know once we connect all the points and follow the entire track, it's going to give us a triangle, and we see why from the graph. So let's go. Where did we start off from? We went from where? M to O. So we're going to write that down. M to O, to O. So that's the first part we take in. And then the second part we take in. Let's look at the graph. Now that we're from O, we're going straight from O to N. So we're going to write ON. But based on the information we have up here, which one we have? We have ON, but who don't we have? We don't have MO. We don't have MO, but we have OM. And what we should remember is that they are in the opposite directions. So one is going to be the negative of the other. So if you're going from OM and that's positive. If you want to go from M to O, it's going to be negative. So we know this means, what should I write? I know this means negative OM plus ON. How do I find negative OM? I just multiply everything in OM by a negative. So we put the negative. What is OM up here? OM is what? 3, 2. So we put 3, 2 plus, what is ON? ON is 6, 5. 6, sorry, and 5. So we break this down. So we're gonna have, once we apply the negative to every number inside. So what's gonna happen? This is gonna become what? Negative 3 and negative 2 plus 6, 5. So let me just pause right here. Everybody with me on how I got this? How we got here? And guess what? This question has come over and 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 over. I'm trying to get us to do as much as this basic stuff so that we can start looking at actual questions. And y'all gonna realize everything I'm focusing on right now is what has come for CXC over and over and over and over and over. This is the first half of vectors. So once you understand just the basic stuff, you should be perfectly fine for the first half of vectors before I teach you the second half. So let's go. We could take it from here. Remember, we add in 2 things. So you're going to add the first top numbers. You're going to add the top numbers. And then you're going to add the bottom numbers. So essentially, what does that mean? You're going to add the X values first, and then you add the Y values after. So all I'm going to do is create one column. So what are we adding? We added negative 3 plus 6. Everybody see how I get it, right? It's just this number plus 6, the 2 X values. And then you're going to have negative 2 plus 5. So what am I adding? Nobody ain't see the mistake I made when I put 2 X's. What should be here? Here should be a Y. This is a 6 and close bracket. So let me see if we remember our integer laws. What's the answer for X? Excellent. Positive 3. Because negative 3 plus 6 is positive 3. What's the answer for the next one? What's the answer for Y? 3 again. Very good. Excellent. So that means then, what does this tells us? This tells us that MN, because that's what we're finding, MN, to go from MN, we needed to move 3 to the right and 3 up. Let's see if that's true. Let's look at the picture to see if that's true. Where's M? M is here, right? How much did we have to go across? This is 1, 2, 3. And how much did we have to go up? 1, 2, 3. So that was 3 upward movements and 3 right movements to move from where? From M to N. Everybody seeing the connection now? All right. So let's keep it moving. Let's keep it moving. We just want to touch as much as we can today. And then on Monday, we're going to try to get some practice. So this is the second part of vectors. So we have successfully covered the first part of vectors. Vectors is actually a pretty short topic. So it's all about understanding that concept, okay? So let's look at vector equations. So let's look at this diagram here. I love this one because this part is like a puzzle. Remember, we spoke about the different ways to represent a vector. So let's look at dm. We know one way to represent dm using our arrows, don't forget, is one way. But what letter did they represent that movement with? Anybody seen the common letter that they use to represent that movement? What letter did they use to represent moving from D to M? Exactly. Common F. Common F. Everybody seen it? Come on, talk to me, because this is a whole brand new thing now. This has nothing to do with what we were doing before. This is a brand new concept. So I need to know that y'all seen it. So to move from D to M, they call that vector F. And how do you know it's a vector? There is an arrow. It must have an arrow. All right, what other vector did they give us, guys? They gave us DC. So how do I move from, sorry, not DC, MC, sorry, MC. We got MC. What letter did they use to represent MC? Excellent. Keeping in mind, look at the direction. From M to C is D. And as we see here, there's a few others. We have OM represented by E. We have AO represented by A. We have AB represented by B, and we got BC represented by C. Let me ask you a question. Is AD a vector? Look for AD for me. And tell me, is it a vector? So I have one answer so far from Gwen. Anybody else? Is AD a vector? How do we know? And students, let's make this mistake all the time. How do we know it's not a vector? There's no arrow. So guess what? There's at no point in time can I travel along this line. So if, for example, if you want to get from A to D, guess where you got to go? All the way. You either could go through here or you could go through here. But you could only move where there's an arrow. Everybody see what I'm saying? Okay, so guess what now? There's a combination of moving from one point to the next. Suppose I ask you using the letters A, B, C, D, E, how do I get from D to C? Which two letters we need to look at? If I want to move from D to C, which letters do I have to look at? Excellent. So guess how have we been going from one vector to the next? What operation were we using? Anybody remember when we were doing it before? What operation was in between moving from two vectors? Who's this calling me? Asha can't answer now. Send me on WhatsApp if anything, okay? Oh, she probably got kicked off. All right, so let's go. Anybody could tell me what happening? If I want to combine something, how do I combine the two letters? What operation allows me to combine two movements? Anybody want to try? How do we put things together? What operation allows us to put things together? Yeah, addition. So DC would simply just be what? F, because I got to go through F first, plus D. I hold on there because some person's calling me. I don't know if something happened. So just give me a minute, okay? Hi guys, can you guys hear me now? Okay, it seems like people in my neighboring areas losing current, including some students. So just in case my stuff shut off as well, you guys just know that current gone, okay? All right, so let's continue. So everybody understand how we get F plus D? So let's go. Let me ask you another one now. Suppose I want AC. Don't forget, I made a mistake and forget my arrows. Don't forget your arrows. Suppose I want to go from A to C. What route we need to walk? No, everybody's seeing it, but once it's not covering the diagram, you should be okay. Because something going on with the Zoom settings, so you can see some boxes blocking some stuff, but just look at the diagram so long. You see the diagram at least? Very good, everybody, because let's look at it. I want to go from A to C. That means I have to go along B, so I put B, and I need to also go along C, so I'm going to add plus C. But guess what I'm going to do now? Suppose I want to go from M to A. Let me see if anybody thinking. Suppose I want to go from M to A. What would happen? Try that one for me. Okay, so Gwen thinks it's E minus A. Anybody else? Okay, somebody else said E minus A. Anybody else? But look at it, guys. We want to go from, to get to A, what do I have to do? I got to go from M to O. But watch what direction I'm going in. Me going in the opposite direction of E as well. So guess what it's going to be? Negative E. You're still going to say plus. And then you're going to go from O to A, which is in the opposite direction. So it's going to be negative as well, minus A. When you simplify this, what does it become? Negative E minus A. All right, hold on again, sorry. All right, sorry about that, guys. So let's go. We almost finished. We're gonna end here today. We're gonna stop here after we kind of master this part of vectors. So let's see if we can do so and be as comfortable as we can with it. So as I was saying, everybody see why it's minus E minus A? You realize we're going in the opposite direction of E and the opposite direction of A. And the only thing in maths, we know that they had a clash, so we had to rewrite it. Now, guess what? This is the part in vectors that students just get confused. You see, whenever you have something like this, you got to factorize it. In this specific example, what do I factorize out? What is common here? And I'm not telling you this, y'all have to figure out this one on your own. What is common between negative E and negative A? Remember, there's three things you should be looking for. Is the signs common? Is the coefficients common? Or is the variable common? Which one is common here? Excellent. The signs are common. So you pull out the negative sign. So what's going to be left back if you don't pull out the negative signs for both? It's going to become what? E plus A. This part here, this section here is what is mashup students. And as we start to look at past paper question, I'm going to remind you why I was teaching you all the factorization part. So just remember, the last thing you need to do whenever you're doing this is to see if you can factorize. If you can, do so. Everybody with me? Let's try a few more. Another thing I want you to know is that each destination has two routes. Because let's be real, there's another way to get from D to C. There's a longer way. Because I could get to D, I could get to C from D by doing this. Follow me. And that's something you need to know as well. You could have gone here, and instead of going down, you could have come here, go there, and go there. Everybody see that? So that means you would have gone F minus E minus A plus B plus C. Everybody see where I say it's like a puzzle and you just got to follow along each thing? The truth is vectors is not hard. You just need to understand the point of doing what you need to do. Okay, so let's continue. Let's do one more for the road. I would like you to tell me, how do I get CE? So some people could give me different things, eh? Some people could take different roads, but I want CE. How do you get to CE? CE. So let's do two of them together, actually. So let me move this across, sorry, because it's probably blocking, right? So let's take the down and across method before we do the left and down. Or let's do the short one first. So let's go together. So we're going to go this way first to get to E. Why nobody ain't tell me ain't gonna E? I mean, O. So sorry, guys. Tired. Okay, so let's try again. I want us to go from C to O. Y'all know it's a struggle in these streets. So this is where we're going, C to O. And like I said, we could go two ways. We could go from the left-hand side and the right-hand side. Let's go the left-hand side first. So what should I write first? What letter should I write first? So Gwen said negative D minus E. Anybody else want to try? So keeping in mind, we're going to go together. For me to get to O, going in the left direction, I need to go from C to M first. And that represents what type of movement? Because it's the opposite direction of D, it's going to be what? Negative D. Everybody see that? We're going to put a plus sign because we're putting it together. Okay, somebody said no. That's perfectly fine. So let's look at it again. You weren't here when I was talking about it. But if a forward movement is positive, a backward movement is negative. You see me? So if moving from M to C is positive D, going backwards from C to M gonna be what? Negative D instead. You understand how I get negative now? Okay, so we're gonna have negative D. So we put in the plus sign because when you're putting them together is addition, and then you just simplify it after, right? So we want to get to O. Where do we go now? We go from M to O. And if I want to get from M to O, is that a positive E or a negative E? Everybody? Excellent. Because it's the opposite direction of the vector. So it's going to be plus negative E. Now we know why we can't leave this like that, because we don't ever leave our clashing signs. So what does this become? This becomes what? Negative D minus, because a positive and a negative turns to a minus E. You feeling a little bit better about it now? Okay, let us try the long way. How do I get the long way? So let me just move this down and use above. So I'm going to erase this. And the truth is, I think I want y'all to write down these examples, because this is the perfect example to use in managing these kind of things. So let's go. We want to go from C to O again, but instead of going to the left, we're going to go to the right. So where do I go first? I got to go from C to B, and then I got to pass through A to get to O. Agreed? So let's go. CA with my arrow. I'm going to always emphasize your arrow. You don't put your arrow, you lose a mark. So let's go. Where are we going first? We're starting off at C and we're trying to end at O. I realize I put the wrong thing again. Guys, help me. I'm struggling. CO. So let's go. Woo. We're ready. What letter comes first if we're traveling downwards? So Gwen said negative C. Anybody else? Anybody else? Excellent. So we have negative C because we're going in opposite directions. We put negative C. I'm just going to put the plus in a different color so we see why we're putting it in a different color. Then where do we go from there? We go, what's the next step? Excellent. Negative B. Very good. Plus what? Is it negative A though? If we're going from A to O, it's just going to be plus positive A, because you realize the direction is a positive direction. All right, so let's go. What's going to happen for our final answer? Our final answer is going to be negative C. This is going to turn into what? Minus B plus A. This is the longer one. Everybody see that? How you feeling about it now? A little better? Okay, let's just try one more. Let's try one more and then we're gonna leave it there. So one of the things I need y'all to do for me though is remind me where we ended off. Oh, we could do this then. Oh, so let's answer these questions. And that's what we're gonna do. So that's perfect practice. So what I'm gonna do, I'm gonna crop this picture from here so we could see it better with the table. Okay, this one ain't look good. So let me get another one. Sorry about that. If we could finish vectors this week so that we could do matrices in practice, that means we could answer question number 10, you know, guys. Y'all know that? If we could finish this before the end of February, that means we could answer question 10. That's the last question on the CXC exam. And that's what I'm trying to get us to do. At least go through all of the information so that we could at least start practicing past paper questions. All right, so they did the first one for us. Let's do AD. Just practice. Correct. So let's go, guys. AD. Let's do the shortest route from A to D. So let's go. Let me zoom in a little bit. And I zoom out because obviously the Babylon system working against me. So let's go. We want to go from A to D. What letters we need? Talk to me. What's the first? We're doing it the short way. So that maybe we're gonna go through O to get to D. So let's try to send me the whole thing, the whole thing, the whole thing. Or you want to do it step by step? Want to do it step by step? So let's go. If we want to get from A to D, my thing sticking in a don't know why. Okay. It's gonna be A. Everybody agree? Because we're gonna go from, we're gonna go this direction first. We're gonna stop here. If my thing would stop sticking, that's all right. We almost finished class. We're gonna tug it out. So I'm gonna write, oh my goodness. All right, just write it in our book, please. Do me a favor. Do me a favor. Do me a favor. Copy down this table and copy down the diagram and do the diagram for homework. Whenever the internet drop, everything does lagging. Everything lagging. Everybody hear me? So do this for Thursday for me, Monday, please. So copy it down and let me know when y'all finish. I think everybody. So tell me the truth. Y'all think y'all can handle this one? Y'all want to try it? Okay, so do this for homework, and that's the first thing we're gonna do when we come on class on Monday. So just let me know when y'all done copying, and then you could leave. And one of the things I want to do is I have to upload the video from last weekend. Don't forget Sunday, we're going through question number 3, functions, relations, and graphs. If you know you are weak in that area, try to attend that session. Obviously, we're going to practice more later down closer to the exam, but this is for people who feel like they're a lot shaky and need some help remembering and revising, okay? So we definitely have session on Sunday, 5 p.m. on functions, relations, and graphs. Question number 3. All right, some people say they take a picture. All right. No problem. The weekend class definitely is a mandatory thing. So just make an extra effort to attend. I got you guys. I got you. Because we're going to have to start working on question paper 1s soon. So we need to just try to complete paper 2s as much as we can. Quadratic equations coming on the exam. Yep. Which part of quadratic equations? The graph of quadratic equations and all those things? Yeah. Yep. I have to do a separate session just on that. Because that's question number 6, 7, no, 8. That's question number 8, 9. But outside of that, are you guys okay? Are you guys keeping up? I know it's a lot of work, especially for those persons who have full-time jobs, for those who have kids. I just want to tell you guys have been doing awesome. We get in there. We just got to continue to push. It's going to be exhausting. It's going to be a lot of work. But if you continue to push, trust me, ain't no feeling like getting your results and knowing that you passed because you do everything you need to do. You don't want any regrets. You don't want to feel like, I could have stayed up a little later. I could have read the video, watched the video a little longer. I could have done a little bit more. That's the worst feeling to have. And ain't nobody got no money, guys. We broke. So don't spend no more money. May want to know back in this class. I never had a repeating student. So put in the work now. You can sleep for the rest of the summer because you ain't gonna hear my voice again. So put in the work. That's the last thing I want to tell you guys before we end class. I wish you guys the best. See you on Monday. Bye. Let me know if anybody ain't finished before I leave so I could just wait probably 2 more minutes. But if you're done, you're free to go. Trey, have you finished or are you still writing? Let me know before I leave. Okay, I guess you're busy.